A very warm good afternoon to all of you, and thank you for joining us here today for this webinar on GIS for transport and logistics. My name is Sakshi Singh, and I am Manager Partnerships and Communications at the Association of Geospatial Industries, that is AGI. I understand we are in the midst of festivities and a World Cup semi-final, but it is also a special occasion for the GIS sector, with it being the GIS Day, which is celebrated annually on the third Wednesday of November every year. GIS Day is a global event that brings together individuals, organizations, and institutions to recognize and showcase the power of geographic information systems. As we all know, GIS is a technology that helps capture, analyze, and present spatial or geographic data, providing valuable insights into our world for various sectors. So, coming to the theme of today's webinar, that is transport and logistics, GIS has a pivotal role to play here as well. It helps optimize operations, improve efficiency, and enhance decision-making processes. And there are various application areas where it plays an important role, such as route optimization, asset tracking, disaster response, urban planning, and so on and so forth. And all of these areas and applications of GIS in transport and logistics are what our speakers will throw light on today. We have with us Mr. Milan Dave, who is the managing partner of Bhugol GIS, Mr. Sai Venkateshwar, manager pre-sales Esri India, and Dr. Chidambara, head of the Department for Transport Planning at the School of Planning and Architecture, Delhi. So a warm welcome to all our speakers on behalf of AGI and on behalf of all our audiences today. So without further ado, I would like to invite the first speaker, Mr. Milan Dave of Bhugol GIS, to share his views on the topic and his insights with all of us.
Hi, happy Diwali to all, and thank you, Sakshi, for that very good introduction to me and all the speakers that are here today. I know all of them are taking time off from an important holiday season, so we'll try and keep our presentation as brief as possible. I'll go ahead and share my screen. I have a brief presentation and then a discussion to follow up. Bear with me if this takes some time to load, but Sakshi, just let me know if this loads on your screen.
Yes, it is visible now.
Okay. I'm assuming it's visible to most people. So welcome again, everyone. I have a very brief outline of the presentation, and I will try and make it even more brief as I go through it. But basically, I wish to just talk about the topic of today in 4 parts. This is based on the mandate given by Sakshi, and essentially to talk about how GIS works its way through transportation engineering, which is my own personal background. I'm a civil engineer by training, with most of my 20 years plus spent in transportation planning and execution. I have to be honest with you, honestly rediscovered GIS. This was not something that was very actively taught during my academic pursuits, but as I worked through the professional career, the GIS increasingly became a part of what I was doing. And hence, I'd like to talk a little bit about GIS. And very briefly about Bhugol, the organization that a few of us lead. It's a team, really. I call myself the managing partner, but there are all of us who manage the show at various times. And then to summarize it. So quickly, without, as she said, much ado, firstly, thank you for inviting me. This day today is the GIS day, and it's really significant for 2 reasons, okay? And I read a bit about it, and it said Jack Dagremont, the founder of Esri, really brought up Ralph Nader. So my first reason is Ralph Nader is one of my favorite persons and personalities, a very interesting activist who really talked about, and the reason he said this, we had to celebrate GIS Day, was he wanted to bring geography to the masses. And today, when we look at GIS, I believe there's nothing more important or more powerful than this technology, which is really bringing a very undervalued science, you may say, to the masses. Geography is one thing that many of us have undervalued over the years, but now as many of us in this community work through GIS, we're realizing how powerful it is. But I think the other important reason is, and this is a friend of mine who pointed out today, is November 15th is the day when Don Bradman scored his 100th. So any of you who are here who are cricket fans and want to get back to watching cricket, this is also an important day for both of us, GIS and cricket lovers. So welcome again. I'll get through my slides as quickly as possible. First off, just going back to the introduction, transportation and GIS. Many of us have asked or may ask, what really is GIS and how does it play a role? Well, according to professionals such as I who work in transportation, we believe that this is something that touches every phase of the transportation domain. And it is something that we believe is inherently important in transportation, the idea of geospatial application. So it cuts across the complete life cycle. Whether you're doing the transportation planning, you're doing designing, engineering execution, the actual project monitoring, or finally operations and maintenance. And this is applicable everywhere, whether you're in the transportation networks of roads, highways, railways, tunnels, urban transportation, logistics, and ports and aviation. But also what's very important to understand is GIS by itself is no more a standalone isolated technology. It encompasses a range of different technologies, and hence you call it geospatial technologies or GTs. And that could mean things such as Earth observation, satellites, scanning. You have state-of-the-art scanners today that would go out and scan the physical environment and create digital twins, the spatial analytics, LiDAR, and so on and so forth. So really, the overview is that the GIS by itself is very important in the transportation network, as we all know. Just refreshing the idea here. So to quickly go through where do GIS gets applied, and I'd like to go through a couple of quick slides as we have talked about, and maybe some of this is already known to people in the community, but to refresh it again, when you look at highways, tunnels, urban transportation, it's an area which is very much applicable to geospatial technology. And there were times when these things were not available and traffic studies, alignment designs had to be done manually or had to be done through AutoCAD systems and so forth. The richness of the spatial data and being able to integrate various layers of information in a geographical space has really revolutionized this whole engineering part of of transportation planning in roads and highways. In fact, one of the reasons I got introduced to GIS was in the process of having to design a tunnel where there was no way we could go out on the site and take boreholes. If it was not for GIS and for the ability to analyze satellite data, we would probably never have been able to design that particular tunnel. So alignment designs, route analysis, demand assessments, these are all things that today we know that any transportation engineer requires its GIS enablers in them. And hence today you see softwares that all have integrated GIS applications. So a quick overview of that. The same is the case when you go to aviation and ports, whether you're doing traffic studies or you're doing operations planning. We end up designing airports where we have to identify obstacle limiting surfaces. We have to do on ports what we call SLAM, simultaneous localization and mapping, automated port operations. And all of these today is possible because of GIS and being able to visualize and model the port operations. These are but some of the things where GIS is increasingly now, and geospatial analytics, as we all know, is being used in aviation and ports. So across the wide spectrum of transportation, right from the project life cycle, from planning to O&M, and in various sectors, we're beginning to use GIS applications. Well, But it doesn't end here. And what's happening is this whole technology is rapidly increasing and rapidly accelerating. So it may not be a surprise to some of us in the community of geospatial specialists. But I tell you that there's a lot of lay people who would today be in wonderment when they hear that there was an autonomous ship that actually took off from the UK and ended up in Massachusetts, completely autonomous, without a crew. And the Mayflower autonomous ship, the picture that I show on the left here, is one of those which was used using geospatial technology, AI and MS, and successfully crossed the Atlantic. The same is the case today for autonomous vehicles. We are all hearing about it. We are all learning about it. In the West, these have started to become introduced. They all continue to thrive on a converging space of geospatial technology. So really, when you talk about transportation and GIS, you cannot underestimate the value of this technology as it starts embedding itself in these sectors. These really are what one would say are the geospatial technologies that are being used in transportation. But then coming into us. So since Sakshi very clearly said that, we wanted a brief introduction of how GIS is used in transportation, but go on and talk about what we are doing. So just a few brief things about our case studies and what we do. Bhugol really, we're standing on the shoulders of some giants. I have just stepped into it, I and our team. This is an organization that was incubated by some really brilliant minds at IIT Bombay. They created their own proprietary tool called Gram++. Some of you might have heard of it. We can talk about it later on after the meeting if some wish to know more about it. But it's one of the few indigenous GIS tools that we use within Google. We are a committed geospatial products and solutions firm. We sell the products, but we also create solutions for different sectors. And really, right now, we work in 3 different areas. Number 1 is transportation and logistics. Second is ESG. For those of you who attended previous AGI conferences, you might have heard about how important GIS is in the ESG sector. And finally, the health sector. So Google is a small, mid-sized team. We're based out of Mumbai with one office overseas, and we're working in these 3 sectors. So just to go through some of the projects that we've worked in the transportation sector within India. One of the most important or interesting projects that we've worked is for a private investor in the road sector. It was called Gram Roads, and it's a GIS tool for highway planning. As I mentioned in my earlier slide, a road project right from planning to design to execution to monitoring and O&M requires a lot of data that needs to be processed for decision making. This particular case came to us when the organization was investing a significant amount of funds into a road project which they wanted to ensure that takes place on time, is monitored properly, and complies with the ESG compliances which are required today. We created a Gram Roads tool. As you can see some of the screenshots that's out there on the presentation. We were able to integrate about 35 different data layers at one time, and people were able to filter through it, look at how the tree plantations were going through, how the construction supervision, the monitoring, and so forth was going on. This was all ultimately put on a geo-enabled web portal, and the road assets were being managed. So today, if one needs to know what toll is being collected remotely from their head office at a remote location away from their office, they are able to manage that. It's also integrated with their own ERP system. So this is one neat thing that we were able to do. It's somewhat simplistic, but very, very useful. You might have seen in some previous presentations that one of the critical things happening across India are the slope stability issues in Uttarakhand and in the northeast areas. We work a lot with other disciplines. We have geotechnical engineers, slope stabilization engineers, and slope protection engineers. We have been able to collect data on hilly parts of the region in the country, especially in certain states of the Northeast. We have analyzed this data. We've created our own platform, which is now able to give you a risk assessment if you're planning or designing a road through some of these hilly regions, and create for the developers a risk mitigation mechanism so that they are able to design and align their roads and avoid landslides and are able to create safe corridors. We're proud to say that in a few of the roads that we constructed and we were able to design the alignment, we've had almost minimal damage to the areas, whereas in some of the other surrounding sections, there were significant damages. This is one application of geospatial technology that we used along with people in the civil engineering and geotechnical engineering to create road alignments in risk-prone areas. And it's part of the resilient infrastructure concept that everybody is now working on. When you go to urban transportation, we were assigned to develop TOD. TOD is essentially transit-oriented development. The idea is that while you build public transportation and metro networks, you also want last mile connectivity. You want people to be able to travel to the metro stations, walk to the metro stations, or bicycle to the metro stations. At the same time, you wish to create areas where the land use is in alignment with the transportation. And I'm sure one of the speakers here from School of Planning will most likely elaborate on it, and Dr. Chidambara will probably have more to speak on it. But in particular, here we use GIS to create digital maps and digital twins along 22 transit stations. We took 17 planning districts, and we again created a geo-enabled tool, which then allowed the decision makers and planners to accurately forecast and define how the land use patterns around the metro stations should be designed so that it is in alignment with what now is beginning to happen in India as we are beginning to create TOD policies, where the FSIs, the real estate development, all of that is aligned with the public transportation. This is again possible with smart decision-making tools using geo-enabled and GIS analysis. So this is one particular case where we created one and it's now being implemented. Finally, one more thing, metros and large capital investments today have large impacts or significant impacts on environmental and social aspects. People are being rehabilitated. You want the tree plantation. We heard in Delhi that they stopped construction the other day because the air pollution was getting really bad. It's now being adopted across India where people have started asking us and project owners, they want to create a GIS-enabled portal so that they are able to visualize large linear construction projects in city and urban environments, able to monitor tree plantation, able to monitor how the dust is being controlled, what are the safety features on the project. These snapshots that you see on the screen are of a web portal where all sorts of data sets are being integrated. And by looking at a map and looking at a GIS-enabled portal, the lending agency and the owner agency and contractors and all the stakeholders are able to closely monitor the project. The idea is to democratize this whole project construction aspect as well as make it visible to as many people as possible. Next is a case where really a real estate developer wanted to identify areas of better investments, wanted to figure out what are the historical real estate pricing and the impact of new transport investments. So in the city of Mumbai, we created this land use transportation map using which, and by integrating certain algorithms and data sets of historical real estate data, the real estate investor is able to now evaluate and create a number of what-if analysis using maps. Again, an interesting aspect of how one uses GIS and geo-enabled technology in order to create value for a business. And this real estate company is now beginning to deploy this portal across their enterprise and are using it to make smart decisions when it comes to investing their dollars into real estate in India. In the logistics sector, we've created a web-based portal that integrated the geo-enabled technology. This was a logistics park, an SEZ park, and they wanted to identify things such as hazard warnings, wanted to figure out improved operations. This was particularly important because in this case, the developer or investor was an overseas investor. The neat thing about this particular solution that we created was we also at Google have created an advanced weather warning system, and we were able to integrate which is called Gram Avas. We were able to integrate this Gram Avas with the geospatial map, and now they are able to foresee if a bad weather condition is coming into the logistics park and then mitigate those solutions. So these are just some of the cases in which we at Google have been using GIS for transportation projects as well as for SEZ operations and logistics. So in summary, all that we'd like to say here is adoption of GIS and geo-enabled technology clearly offers great promises across all sectors. But I think it's equally important to recognize that it does remain underutilized in India. So while we're making great strides in automation, AI, ML, and we are combining it with GT and to develop autonomous vehicles and so forth, it's the challenge we face in India. The biggest one is the awareness, and I think again this is going back to thanking AGI and Sakshi, where this awareness, these little discussions that we have, where we keep repeating what are the great enablers resulting from the adoption of GIS are really useful because we need to get the word out. There's a really great need for awareness and to embrace this new technology in the logistics and transport sector. I've underlined that with one little statement that we came across just yesterday where they said the simple transportation projects are today having 4.7 lakh crores in cost overruns. And 4.7 lakh crores is not a small amount. We believe that by using smart methods, including adopting GIS technologies, could possibly help mitigate these cost and time overruns. And this really, in summary, is what we at Google would like to share with the people present here today in terms of how we enable and use GIS in transportation and logistics. Thank you very much. Thank you.
Thank you. Thank you so much, Mr. Dave.
Yeah.
Thank you for your wonderful presentation on how the technology can be integrated across the life cycle for transport and logistics projects, various sectoral applications that you've showcased, and also some of the projects of Google GIS relevant to this sector. So thank you once again. I'm sure anybody in the audience, if you have any questions for Mr. Dave or for the other speakers, you can please paste them in the chat box. And towards the end of the session, after all our speakers have delivered their address, we'll be taking up your questions. So now let us move to the second speaker of the day. That is Mr. Sai Venkateshwar from S3 India. Mr. Venkateshwar, please, if you'd like to share your screen and share some of your thoughts.
Thank you, Sakshi. Good afternoon and happy GS Day to everyone. And thanking AGI for this invitation to discuss the potential of GIS in transportation and logistic management. As we all know, the transportation and logistic industry is a critical element of our Indian economy or the global economy, where its efficiency has a direct impact on the overall supply chain process and also to the customer satisfaction. So this important statement making the transportation professionals to choose GIS as their first choice for bringing their data onto the maps and conducting different types of in their planning process or analyzing based on the location based objects such as transportation networks, boundaries, environmental data, and topographic. So the GIS technology also helping to create a seamless flow of information from one stage to the other. So with this GIS, the information from your planning process can be brought into the design process and which can be also carried out into other areas such as drawings, operations, and maintenance. So looking how GIS works in the transportation and logistic. So the first step is the data collection. Data is an important part where the GPS devices or the sensors or other data sources which collect the location and status of data from the vehicle assets is required. And we need softwares. So the GIS software which analyzes these data to provide the insights into the transportation and logistic operations. Finally, the data visualization, where the GIS technology will help to bring the data onto the maps or create executive dashboards, which enables the users or the decision makers to see the locations and the status of vehicles and assets in near real time. So there are various, as the previous speaker spoke on different applications. So few of them are being listed out. The first, which I want to talk is a route optimization, where the GIS can help to determine the most efficient routes for transportation by considering different parameters like traffic congestions, road conditions, and what are the delivery schedules, which helping by analyzing these variables, which helps to optimize routes, which reduces the travel time, the fuel consumption, and also the important is the cost. Next, the fleet management, where the GIS helps to track and monitor the location of vehicles, which allows the logistic managers to make informed decisions about their dispatching or routing or scheduling their logistic operations. The important other thing is the asset and warehouse management. We need to understand the conditions of the infrastructure such as roads, bridges, and warehouses. How are they? What is the conditions which are being easily accessible or not? The next one is the demand analysis, which is an important sector. Using the demographic and market data, you can identify the areas with high demand, so where you can deploy your logistic operations, or the public transport is also one sector where the demands are there, you can improve your facilities or operations. So which Milanji also spoke on the one of the disasters where the risk assessment. So the GIS can access the potential risks and vulnerabilities which are important in your transportation network. So by identifying which can be through disaster or through accidents. So by identifying these risks, so the managers can mitigate the potential disruptions to the supply chains. Among the other than these application, the which one is an environmental impact, which we need to talk, whereby analyzing the data from the fuel consumption, emissions. So again, it makes understanding by these data sets, you can take informed decisions to minimize the carbon footprint, which we have seen the different types of climate changes. And also the one more application on territory optimization is one more application which we can talk on. So to do these type of different types of use cases or applications, so these are the different types of network analysis we follow to derive. So one is the routing solutions, where you can find the shortest path from point A to path, considering different parameters like traffic, terrain, and everything. And also the service areas for any business or logistical operations. So which falls considering the time and the distance. Similarly, the closest facility. So again, here the considering the travel time and travel distance, so you can derive the best routes for driving directions. And the calculating the least cost paths, which calculates from the origins to the destination. And the next one is the vehicle road problems, which derives the optimal routes, best routes, which reduces the limited resources, utilizing limited resources and uh, cost effective. So these are the GIS benefits in using in the transportation logistic applications, where the GIS implementation will streamline these transportation and logistic operations, meeting the deadlines in time because of easy to use functionalities, where the efficiency is being improved. So getting different types of insights and reduction in cost or different types of executive decisions can be maken. So accessing different types of accurate, timely, and multiple different layers, and understanding or creating different types of real-time analytics, you can have a better operations. So understanding the high risk areas, historical analysis, or optimizing the route where you can maintain the safety and security. So we can understand the competitive advantage also. If you are offering faster, more reliable, so you will be competitive advantage. And finally, the customer satisfaction is important thing, where you deliver the uh, projects or the items or deliveries in accurate time, prioritizing different work orders, linking with GIS or other components. So this GIS technology trends has been increased because the amount of data generated by these GPS sensors or the GPS GIS sensors or GPS devices, making use of the big data analytics. So the cloud solution is also becoming more popular, enabling the greater accessibility and collaborations. And we see the mobile applications are being used both on the field or in the operation and to track and manage the transportation and logistical operations in real time. There are a lot of use cases on our uh, website where you can look for logistic and distribution or the transportation. So in the interest of time, I'm going to talk on one of the use case, which is a route optimization. So here a government department, which are a logistic company, which is in headquarter, is required to deliver its supplies to their different offices or mandal offices. So considering some of the technique like 2 turns per mandal office, and which happens monthly, and delivery is the first day of the month. So here there are multiples. They were using some 11 trucks with no GS planning, which they wanted to reduce, considering the first scenario as the trucks to be reduced to 6, and it as it serves 8 mandals, and considering also the maximum time where the truck can travel, which is a 300 kilometers, whether it will be finished in a day or any relaxation for any additional day to be considered. In a similar fashion, the larger trucks to be considered with a payload of 55 tons. So whether we can switch to a 2, and what is the maximum time relaxation to be delivered is required, whether it's a 3 days or 4 days. So this is a small application which we have taken. So in states, the blue point is the source where it is the headquarter, which is the green points are the where to be delivery to be done. So considering things, so this is the time period. So where we have been set at what period does it will accept the the delivery, and these are the time window for all other points, the destination, and what is the service time at each location. So when it is going to accept the delivery or when it is a final time, and any relaxation in the time. So all these parameters and considering different values like the break time, journey time. So all these been defined to the software, given the time. So these are some of the estimations or the inputs. So what is the 36 hours, what is the maximum distance it can be travel, what is the fixed cost, and it will give the cost for each truck also. So giving all these parameters or specifying all these values, so running this, how much time, what is the final results. So solving this problem, so it will give the final results. So covering, so among the 43, so there are 42 has been covered because of some topographic issues or topographic terrain areas. The one has been not covered. So you can refine this output, giving the additional time window. So in this way, you can run or you can reduce the routes to 2, and you can further finalize this output. So coming to the conclusion, so the GIS technology has a potential in revolutionizing the transportation and logistic operation, which is improving the efficiency, reducing cost, and finally the enhancing the customer satisfaction. So by implementing the GIS technologies, the companies can also gain a competitive advantage in an increasing and complex and dynamic marketplace. Thank you.
Thank you, Mr. Venkateshwar, and thank you for your presentation highlighting the various applications of the technology and this very interesting use case that you shared. So now I would like to invite our final speaker of the day, Dr. Chidambara from the School of Planning and Architecture, Delhi, to share her few thoughts on the subject.
Yeah, thank you, Sakshi, for the invite. And I would, I am the last speaker, so I think our previous speakers have already spoken a lot about the application of GIS in transportation and logistics. But I would like to stick to the planning aspects, not focus more on the engineering and the management aspects, and where all we use GIS in research areas, especially in the field of transportation and logistics. So I'll share my screen. Is it visible?
Yes, it is visible.
Yeah, so would like to begin briefly with how how GIS is a very useful tool, very powerful tool which helps us to manage the different types, not only manage but also integrate, correlate numerous types of information that we require in our in the planning, in the design, in the analysis, and various other aspects of transportation systems and facilities, both of passenger transport as well as of freight transport. So main uses that we see in especially in the area of transportation. First of all, we see it helps us carry out a wide range of spatial analysis using different types of attributes, find out the correlation, the spatial correlation, autocorrelation analysis are very interesting tools that enable a wide variety of informed decision making. Spatial visualization of issues, optimization of facilities infrastructure, the operations and management, and overall all of these effectively help planners, decision makers in more evidence based and contextual decision making. So in uh, transport planning, although it incorporates both freight and passenger, but I've just separated the passenger and the logistics part. So in the field of transport planning, one very important area is of network analysis, different types of network analysis, and based on network analysis, a lot of decisions related congestion and where to improve the road connectivity, or all these decisions can be taken. Public transport planning is an important area, route planning of public transport. Another area, infrastructure planning, traffic management, accident analysis is a very important area, another important area. Uh, Transport modeling, accessibility, all these are important applications of GIS. In the logistics sector, I think both our previous speakers have touched upon these specific areas in detailed manner, but I'd still like to point out a few of these. Facility planning and location for all uh, different types of logistic facilities, such as warehouses, delivery hubs. Especially with e-commerce, a lot of importance has come out to this specific aspect. Where do we locate our delivery hubs? Or we have these dark stores that are coming up in for quick commerce delivery, which are opening up in small neighborhoods. So it's very important. GIS can really play an important role in how to plan how many of these should come up, where, what would be the ideal location, where is the customer demand, and so on. And along with it, the last mile delivery optimization is an important upcoming area. Freight modeling, demand forecasting, delivery routing, scheduling to optimize the costs, fleet management, catchment shared optimization. So these are different other areas of applications in logistics. So some of these examples are taken most collated from different sources. So what are the various tools, techniques, and analysis that we perform in the field of transportation? For instance, identification of routes, or best route or shortest route, closest facility, service areas, vehicle routing, location allocation, OD cost matrix. So these are some of the examples where we use GIS. Broadly, if we classify, put the transport system, or look at the transport system, we see that them as networks in the context of transport networks. Networks also have flows, that means movements of people, movement of freights. So we have flows, and finally the land on which the facilities are located, where we look at these. So these are the three layers in which we specifically look at the entire transport system holistically, and where GIS can help us in looking at the or analyzing these through different ways. So for instance, when we look at networks, we can try to look at the network characteristics. What is the network density, for instance? What is the intersection density? How connected is a particular network? Or how a network has evolved over the last few decades, let's say. What is the efficiency of network? In terms of flows, we can use GIS in analyzing various movement patterns, traffic management, route optimization. And the third layer, when we talk, where we sort of uh, bring out a relationship between transport and land use, it becomes even more important tool, GIS, where we can understand which type of lands are suitable, where what is the locational suitability of a particular facility or infrastructure, how well the resources are distributed in space, how accessible the resources are to different sections of the society. So this is one of the examples where it can also help us in doing a very closely monitored evolution, time series data over space, how things change in a short period of time, in a long period of time. For instance, this particular example here, we can use it to do these the example I was referring to earlier of dark stores. So a large number of dark stores open and close in a very short period of time, and it would be interesting to see the pattern, how or what are the reasons, what are the underlying factors that maybe these e-commerce companies can think of while locating themselves. Some examples in network analysis, for instance, what all things we can do. We can evaluate accessibility, connectivity, various types of network characteristics, path, detour. For instance, this right side example is an example of clusters of high and low average detour ratio in metropolitan uh, Copenhagen with using the tool LISA. So global and local spatial autocorrelation are very important GIS tools that help us in understanding these types of carrying out these types of analysis. Shortest path analysis, best route analysis, closest facility. Walkability is a very important dimension when we look at sustainability of cities, and these tools, again, pedestrian detour fact, several analysis can be combined to assess walkability through GIS, and PDF or block length, intersection density. All these are useful tools. And for instance, this map shows what are the areas, which are the wards having low walkability index, medium walkability, or high walkability index. And that can help, or that can facilitate local governments to take more steps towards providing the necessary infrastructure for improving walkability in a particular area. Also, for many a times we want to think what is the best route. For some people, best route may be the quickest. For some, it may be the shortest. So through GIS, it helps us to it gives us an option to understand in both dimensions. If we are giving time as the impedance, or if we are giving distance as the impedance, it can show us different paths. Uh, Also, for OD cost matrix, it's a very important analysis when we teach transport planning to students, where this particular tool can help find the least cost paths between each origin and their closest destinations. But and also it can all give us the exact route as shown in the right image. So it's not just, it's a symbolic representation, which is a straight line, but it can also with the help of GIS, we also know what is the attribute of that particular route, the total time that's actually being created to reach that two destinations. Closest facility vehicle routing problems, we can for instance, it can help us find route from an incident to all facilities. For instance, if there is a if there's an accident that has happened here, and we would like to know which are the closest hospitals in this area, and in real time, if we are connected, it can provide us with understanding of the closest facilities, or also in certain types of vehicle routing problem to, for instance, for if there is a very large fleet management required for logistics companies, it's a very important way to go about it. For route optimization for delivery services, supply chain management in public transport systems, especially, it's going to be more useful in future because of a lot of on-demand services that are coming up. Also, mobility as a service, or MaaS, what we refer to as MaaS concept in public transport systems, is gaining importance across the world, and also probably a lot of these initiatives are taking shape, although in some smaller forms in our country as well. And these companies will really require route optimization to improve their bus schedules, integrate them with other multimodal, to bring about this multimodality, so that passengers do not experience that that great waiting time, and there is more of seamless connectivity. So this can play a very significant role there. Uh, Accessibility is a very important area for uh, uh, understanding the transport systems, whether we are talking in terms of accessibility to opportunities of employment or access to social infrastructure facilities, or even access to a transport node. So evaluation of accessibility through creating catchment areas or service areas, let's say, for instance, of 5, 10, or 15-minute breaks, how we can generate these areas that are highly accessible and or with lower levels of accessibility. Uh, Public transport, the accessibility is also used a lot in across, not just in academics, but a lot of transport agencies. For instance, TfL, Transport for London, uses this public transport PTAL, what we refer to as PTAL, in accessibility assessment of public transport, which provides us a very comprehensive understanding of how well an area is connected through public transport. And it takes into several attributes such as transit stop, what are the location of the transit stops, what's the travel time to each transit stop, what is the service frequency, and overall then generates a holistic accessibility rating. So this is a very beautiful map of PTAL for London, where we see in the core area the which has the highest accessibility, and how the accessibility reduces as we move to the outer areas. For demand forecasting, one of the very important areas where we have these TAZs or transport assessment zones, and we can use GIS for, although we use a lot of other softwares for demand forecasting, but such as Visum or Cube, but we can also integrate that with GIS to see to bring out these analysis as well. Actually, GIS is somewhat less explored when we do the demand forecasting in transport. This is another area. One of my PhD scholars is doing a research on e-commerce, freight strategies for e-commerce, and one of the desired line diagrams of various uh, 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 dark delivery hubs and their integration, how the freight movement is taking shape between taking place between the fulfillment centers and between and the delivery hubs. Travel time mapping is an area is very important. It's for very important for real-time traffic management, and it can enable us in dynamically adjusting the routes based on current traffic situations, which can further help in minimizing delays. So that's an very important application of travel time mapping. Or this can also be used for last mile delivery optimization. For instance, on this right side, we have these maps show how what is the travel time in minutes from to a certain health facility. The same can be used also for transport logistics facility, for instance. And if there is a clustering, for instance, this was the earlier scenario, and in the figure below, we see that this is optimized because there was too many clustering of certain facilities in the area. So it can help us achieve improve our economic can make more economic sense to provide or to decide how many number of any facilities we should be providing in a particular area. Also, it would improve the delivery accuracy, meet customer expectations for timely deliveries. Spatial visualization of logistic facilities, for instance, we can consider multiple layers. GIS can help in uh, in providing or considering a range of thematic maps and different layers. So for factors such as proximity or connectivity to transport networks, or other, what are the other freight generating areas, or proximity to customers, density of stores, zoning regulation, environmental impact, all these different layers can be used together to understand what are the potential sites that are suitable for a certain facilities. Location allocation, I think, already was pointed out by the previous speaker. So it's basically selecting facilities from a set of facilities to operate based on their potential interaction with demand points. So again, it helps in the location allocation. Hotspot analysis is very commonly used, I would say, by transport planners and students in carrying out in several different areas of research, but mostly in accident hotspot analysis, traffic congestion analysis. So these, the first two areas are the most important areas where we use this, but these are also used for freight distribution centers. So identify areas which have high concentration of freight movement and logistic activities, or based on that, how to optimize the distribution routes and transportation networks, and evaluate accessibility or connectivity of freight hubs. The same thing, a lot of things are both applicable in freight as well as in passenger transport. So the things that I pointed out for freight distribution centers is also applicable to other transport infrastructure, say airports, or a railway station, or even a metro station. Yeah. Uh, uh, I think Milan pointed out that GIS is not a standalone technology, and that is very important to keep in mind, that we integrate other technology and databases that we have to, when combined with GIS, it can really provide us with very useful analysis and applications. So one of my students who carried out a study on what is the potential of using bicycles in hyperlocal delivery. So in this particular area, he gave these GPS trackers in the delivery person's mobiles, and tracked for over a week. And he compared the bicycles with the motorbike delivery persons. And so this map is a representation of 1.5 lakh plus GPS points of delivery riders which were collected over a week. And this type of map was prepared for bicycles as well as motorbikes. And then finally, using machine learning tools, he modeled speeds of two modes and identified further areas which were more suitable for bicycles over motorbikes. And that's a very important area, because we all want sustainability in urban transport, especially in freight, because freight deliveries are increasing. And if we don't go for sustainable modes, it's going to become a real problem for cities in future. So this was the way he extracted the GPS data, and because it was too many, so we had to trace the GPS data to the selected network at 9-meter buffer, and then create the averages. So that's one area, and quickly I'll just a couple of more slides. So I talked about spatial autocorrelation earlier, and both types, the global spatial autocorrelation and the local autocorrelation, they are both very important to do different types of analysis. A lot of things are not very well explored. A lot of tools are not very well explored, not only by planners but also by in the research field in our country. If we look at internationally, these tools are very interestingly used in different area. For instance, one area is transport equity, where we can identify clusters of areas or population which have lower accessibility. It can be used in traffic congestion analysis to assess whether traffic congestion levels exhibit spatial autocorrelation, or also clusters with similar traffic congestion patterns. And then based on that, we can have informed strategies for traffic management strategies, which shows some significant autocorrelation. Similarly, in accident hotspot identification and freight movement patterns, where we can identify different clusters of high or low freight activity and optimize logistics and distribution networks. Uh, Another very important tool is the use of kernel density, where we can do use these uh, analysis for carrying out different types of spatial analysis. For instance, if we want to analyze and visualize the concentration of transport routes, it can be helpful, or help it can help identify high traffic corridors, or how to plan logistics more efficiently. For instance, in these three maps, they show the cluster of these Amazon warehouses, Flipkart and Blinkit warehouses, and how what is there, where is the concentration. So the concentration, if we look, we explore, even if these companies try to explore and combine with several other thematic layers, such as density, population density, or institutional areas, or several other things, or even the location of industrial land use. For instance, because every company would require areas which have warehouse locations for to come up. So it can be very helpful in such type of informed decision making. Optimizing transport networks by again highlighting the dense clusters of routes, placement of hubs, warehouses, distribution centers. Also, for resource allocation, for facilitating better decision making. So overall, I would like to say that in all of the areas of transport planning, of transport of logistics planning and management, we find the use and application of GIS is quite great. But at the same time, uh, the understanding or is not that great. In If we go to the local government level, it's very difficult to uh, to get I mean to see applications beyond property tax and collection or land use mapping. But I would like to say that GIS is not just about mapping, and we really need to understand the entire potential of the GIS by knowing all these tools and uh, techniques that GIS facilitates us, so that we can have more informed decision making, whether it is with respect to resources allocation or facility distribution, or even a basic understanding of how accessible an area is with respect to public transport. So thank you, Sakshi, for your time.
Thank you so much, Dr. Chidambara. I think this was a very, very, comprehensive and very detailed presentation that you have shared with us, covering so many applications of GIS in transport and logistics, and also a food for thought for all of us. And of course, AGI, since one of our mandates is to help increase the adoption of this technology in the country. So definitely, we are actively working towards this with the help of our members. I would like to thank all the speakers for their presentation today. Bhugol GIS and Esri India being our members, and SPA Delhi being one of our partners. So thank you all for the very insightful presentations. Now, because of the paucity of time, I think We may not be able to have a very lengthy discussion at this point, but let us take a few questions that we can see from the audience. So one is that I can just see, what is the prospect of using geospatial technologies in intelligent operational transportation? So if any of our speakers would like to take up this question.
Yeah, shall I? Can I?
Yes, please.
Yeah. Uh, as I pointed out, see, intelligent transport system, we need to really see how to marry GIS and other technologies, other systems that are there. For instance, big data, cloud computing, all of these areas, even the mobile data that we are using, that those need to be integrated and used with GIS. And intelligent transport systems include real-time information to passengers, even security issues, security on transport systems when we are navigating. So all ITS is used in those areas, and GIS is a very useful tool to convey, for instance, which are that, let's say if we want to analyze a system which is not a very safe area in a public transport system. Let's say you have a metro station and surrounding areas. So it's not just within inside the metro system, but once you come out of the metro system, you have to navigate certain areas. So which are those areas where we need to enhance security? How ITS can help in providing those security measures, or take some provide some interventions that enhances securities. So those are areas where we can take the use of GIS. uh, yeah, so anyone else would like to go on?
I just want to add something very interesting that I came across the other day. We came across a Japanese manufacturer, a geospatial company that's collaborating with a tire manufacturer, or rather an automobile supplier. And they are starting to embed IoT, small micro IoT devices into the tires. And when the cars are running on the roads, they are able to look at uh, the condition of the road and send that data back to a geospatial, geo-enabled portal. And then at the end of the month, the Department of Transportation maps the condition of the roads. And this is just a very different way of managing and maintaining roads, and where geospatial visualization seems to play a big role in creating a whole ecosystem for road maintenance and intelligent transportation system. You already mentioned automated travels and so forth, but this was a very unique, creative way of utilizing this technology, and I thought I would share that. I don't know if it's actually beyond the prototype or not, but I did see a test case of that. So that might be interesting.
Thank you, Mr. Dave.
Yeah.
And I think I can see a lot of questions in the chat box, but probably we can just take one more. So one is, if you can advise, is streaming data for traffic better for data analysis or static data? If you could share your thoughts on this.
So I can answer, like, the real-time data is an important. So traffic plays a major role in route optimization or route planning. So even if you don't have that option, then you can go for a static data, whatever we are available. So I feel the traffic information plays a major role.
Right. Thank you so much. So I think we have already exceeded our time today. So unfortunately, we won't be able to take up any questions at the moment. But I have noted down all these questions, and we will try to have these answered by our experts and shared with you. So once again, thank you to all our speakers and to our audience. And again, this session has been very informative and a very relevant one, I think, for GIS Day. So thank you once again, and let's reconvene for the next knowledge session of AGI. And till then, wishing you a very, very, I I mean, happy GIS Day. Thank you.
Thank you.
Thank you.